In this video, I'm going to show you how to solve two systems of equations where you're going to see some special case happen here, and you're going to get kind of a weird solution. And so I wanted to give you a good example of each of those. Now, in order to cancel a variable, you need to have coefficients that are the same number and opposite signs, which we don't have here in this problem yet. But I noticed that if I wanted to cancel with a positive 2x, I need to have a negative 2x here for the second equation. So I'm going to start by multiplying this equation by a negative 2 so that my x's will have coefficients that are the same number but opposite signs, and then when I add my functions together, they're going to cancel my x's out. So here's my new second function. When I multiply by 2, it's going to give me negative 2x. Negative 2 times 3 is negative 6 for the y, and that will equal 2 times 9 is 18, and so negative 18 here. And my top function that I'm just going to rewrite, I'm not going to do anything to it here, I have 2x plus a 6y and equals positive 18. Now I actually kind of noticed something right away, and maybe you notice it too. So I did this multiplication here so that my x's would cancel out. And normally you're left with some y's and then a number, but I notice that my y's also canceled out, and I notice that my 18's canceled out. And so I have 0 at the end equal to 0. Now, because this is a special case, what this means is that you would have infinitely many solutions. You might see this symbol written down on, like your homework keys, or if you've ever seen that symbol before, infinite solutions. You also might see a symbol like this, which means all real numbers, meaning you can plug any number you want in, and that point will work for these two functions. So what happens is, if you were to actually graph these functions, they are the same line. So any point on the line would be the same point for this line. So graphically, it would look something like this. Now, I'm not saying this is this function, but it would look like, let's graph this equation, and then graph the second equation ends up being the same one. And so because it's the same line, you're going to have an infinite number of points that these two lines share. Okay, here's another case for elimination where you're going to see something weird happen. Okay, so I am looking at my 2x and my negative 2x, and I notice that they can cancel, but I need one of them to be a positive. And so I'm going to multiply here my second function by a negative 1 so that my x's will cancel out. One will be a negative, and then this one will turn then to a positive. So here's my new second function if I make this into a positive 2x. So negative 2 times negative 1 is positive 2 for my x term. 5 times negative 1 is, actually I want a minus here, negative 5y, and a negative times 12 is negative 12. So now my function that I had up top, the first one, I'm just going to rewrite here. I'm not going to change anything, so I had negative 2x plus a 5y and equal to 7. Now in this function, when I add these together, I notice that my x's cancel. That's what I had multiplied by a negative 1 for on purpose. And so I get no x's. But I also notice that my y's canceled out. But on the right side, negative 12 plus 7 gets me negative 5. And it is not true to say that 0 equals negative 5. And so that means that this system has no solution. One way I tried to remember the difference between these two is when you see numbers that don't match, your immediate reaction might be like, no, that doesn't work. Something didn't work out. No, 0 is not negative 5, and no is part of your answer. So maybe that would be a helpful tool for you. And when is 0 equal to 0? It's always true. So infinitely many solutions, like they always match. So just kind of a helpful tool. Visually, the picture for these two lines, if there's no solution, that means your lines, the first line and the second line, would be parallel, meaning they never touch, and that's why there's no solution. And so this would be parallel lines. So let me write that down as well. There we go.